The first glimpse, narrator. Across the endless void of space, a silent revolution is taking place. It is not one of war, but of discovery. We stand at the precipice of understanding the most profound question that has ever lingered on the edge of human curiosity. Are we alone in the universe? The camera zooms in through the cosmic dark, slowly revealing a planet bathed in an eerie green light. A massive, gnarled tree sways in the breeze, its leaves shaped like elongated blades of glass, shimmering in the soft glow of a nearby star. Narrator. In this series, we will journey to worlds far beyond our own, where life exists in forms that defy everything we know. From distant exoplanets orbiting stars light years away, to the frozen moons of gas giants, we explore what life could look like in the most alien of environments. Scene transition, a sweeping shot of the planet's surface, shifting to a group of biologists in futuristic suits, observing through advanced telescopic lenses. Dr. Ilara Jensen, astrobiologist. We are witnessing a breakthrough moment in the search for alien life. We've studied extremophiles here on Earth, microbes that survive in the most hostile conditions. But now, we're looking at creatures that may have evolved under entirely different rules. The scene shifts to a sprawling digital simulation. Planet after planet appears, each more strange than the last. From worlds covered in liquid methane to those with skies of dust and lightning. Narrator. The universe is vast, and within it, the possibilities are endless. But what does alien life actually look like? How might it evolve under the influence of environments we can scarcely imagine? The watery depths. The episode opens with an underwater expedition. A deep-sea submersible descends into an ocean world, the pressure immense, the darkness total. Narrator. On the moons of gas giants like Europa and Enceladus, oceans exist beneath thick layers of ice. These oceans could harbor alien life in ways we've only dreamed of. Inside the submersible, Dr. Simon Rhodes, an oceanographer, peers through the porthole as the light from the sub casts eerie shadows on the alien seabed. Dr. Rhodes. The conditions on Europa are harsh, temperatures well below freezing, constant pressure, and no sunlight. Yet, if we look to Earth's own oceans, we find life thriving in similar extremes. Microbial organisms exist in places where no sunlight reaches, surviving on the chemicals that seep from the planet's interior. We believe that life on Europa, if it exists, would rely on similar processes. As the camera pans out, bioluminescent creatures dart through the water, their bodies glowing in the cold, dark environment. Some resemble jellyfish, others more like squids, but all are beautifully alien, evidence that life can adapt in remarkable ways. Toxic atmospheres. The focus now shifts to exoplanets with atmospheres unlike any Earth has known. A vivid red planet appears on screen, its sky a swirling mix of toxic gases and volatile storms. Narrator. On planets with thick, poisonous atmospheres, life may not breathe oxygen, as we do. Instead, it could thrive on compounds like sulfur, ammonia, or methane. Could alien organisms be so radically different from us that we wouldn't even recognize them as life? Dr. Ava Yates, atmospheric chemist. We've spent decades researching the possibility of life on planets with atmospheres rich in gases like hydrogen sulfide. While such worlds are inhospitable to human life, they might be perfect for life forms adapted to these extreme conditions. These creatures could metabolize sulfur instead of oxygen, and have evolved to thrive in environments we would find utterly hostile. The camera zooms in on a simulation of a sulfur-breathing organism, a sort of cloud of microscopic filaments that clings to the surface of a hot, acidic lake. Narrator. It is a reminder that life, in its many forms, is bound only by the conditions in which it exists. And though the stars may be far away, the dream of finding life in these alien worlds feels closer with every discovery. The Silent Giants. This episode is dedicated to the exploration of gas giants, planets composed mostly of hydrogen and helium with no solid surface. Huge, swirling storms rage across their atmospheres, their gravity and radiation making them inhospitable to life as we know it. Narrator: the gas giants of distant star systems have long been thought of as barren, hostile worlds. But what if life didn't need a surface to thrive? We follow Dr. Michael Voss, an expert in exobiology, as he discusses the idea of aerial life in the clouds of gas giants. Dr. Voss: imagine life floating in the clouds of a gas giant, tethered not to land but to the wind. It could exist in the form of massive, balloon-like organisms, suspended in the thick atmosphere, using solar radiation and chemical processes to fuel their growth. These creatures might be unlike anything we can conceive, but they would be perfectly suited to life in a place we thought uninhabitable. The camera shows a large, gelatinous creature floating in the swirling red clouds of a gas giant, its semi-transparent body glowing faintly as it absorbs energy from the planet's intense storms. Narrator: life, it seems, can adapt to even the most extreme environments. The question is not whether life can exist, but what form it might take, and how we might discover it. The Alien Intelligence, the final episode, delves into the possibility of intelligent life beyond Earth. What would an alien civilization look like, and how might we recognize it? Narrator: as we search for alien life, we often look for the familiar biosignatures like oxygen, carbon dioxide, and methane. But the true challenge lies in the search for intelligence. Could alien civilizations exist that think and communicate in ways that defy our understanding? The camera zooms in on a distant star system, where astronomers are scanning for any signs of artificial signals. Dr. Naomi Hernandez, astrobiologist: if intelligent life exists on a distant planet, the challenge is how to detect it. It may not be sending radio signals, or building cities we can see from space. Perhaps their technologies are completely different from our own, maybe even biological in nature. The search for extraterrestrial intelligence is more than just listening for radio waves. It's about finding new ways to understand how a civilization might leave a signature in the cosmos. The episode ends with a montage of deep space radio telescopes, sending signals out into the dark, while on screen, a visual representation of distant alien cities fades in and out, made of translucent material and bioengineered life forms, communicating through light pulses. Final scene: the infinite possibility. Narrator: the universe is a vast, uncharted frontier. Every discovery brings us closer to understanding the rich tapestry of life that may be unfolding in the dark corners of the cosmos. And as we continue to look to the stars, we know one thing: the search for life is not just about finding new worlds. It's about understanding our place in the universe, and the infinite possibilities that lie beyond our own planet. The screen fades to black, and the final words appear in bold, white letters: Alien Worlds. The series title appears, and the screen cuts to credits, leaving the viewer with the lingering thought of the untold wonders that may be waiting in the darkness of space. The desert wastelands, the screen fades in from black, and the first shot is of a barren, red planet. The surface is cracked and parched, with towering rock formations casting long, eerie shadows. In the distance, a massive dust storm swirls like a living thing, swallowing the horizon. Narrator: in the vast reaches of the universe, there are worlds that seem empty, desolate landscapes where life seems impossible. Yet, as we've learned on Earth, life can sometimes find a way in the most unexpected places. Could alien life exist in the driest, hottest, and most inhospitable environments? Could there be life beneath the surface of the deserts of distant planets? The camera slowly zooms in on the planet, and we see strange patterns beneath the surface, lines that resemble ancient riverbeds. Suddenly, a small rover bursts onto the screen, navigating the dusty terrain. Dr. Elena Cruz, geobiologist: we've always thought of deserts as the end of the line for life, but Earth has shown us that even the driest, most extreme conditions can host life. From microscopic bacteria in the Atacama Desert to ancient microbes trapped in ice, life can be resilient. The question now is, What if the deserts of distant worlds are hiding secrets beneath their arid surfaces? The rover deploys a drill and begins boring into the planet's crust, sending up small clouds of red dust. As the drill breaks deeper into the rock, the camera cuts to an animation showing what might be lurking beneath these lifeless surfaces. Subterranean microbial life that might survive off minerals, or even the geothermal heat emanating from the planet's core. Narrator: beneath the surface of this desert world, water may be locked in deep, underground reservoirs, trapped in pockets of ice or brine. Could there be microbial life existing in the dark, using chemical reactions to survive? Life may not always be found in the lush, green ecosystems we imagine. Instead, it could be waiting beneath the harshest landscapes, out of sight, but thriving in its own quiet way. Episode 7, The Super-Earths. A new planet appears, larger than Earth, its surface covered with vast oceans and towering mountain ranges. This is a super-Earth, a type of planet that is more massive than Earth, but potentially in the habitable zone of its star. Narrator: super-Earths are some of the most intriguing planets we've discovered. Larger than our home planet, they could have the right conditions for liquid water and perhaps life. But what kind of life might evolve on such a planet? And what challenges would its inhabitants face? Dr. Kieran Miles, planetary scientist: a super-Earth could be a planet where gravity is stronger, the atmosphere thicker, and the weather patterns more extreme. It might have the right ingredients for life, but the challenges would be enormous. For life to thrive, organisms would need to adapt to more intense conditions. Higher gravity could mean more robust and muscular creatures, or perhaps a greater diversity of life forms, adapted to survive in different niches. The camera pans over vast, jagged mountain ranges that tower over oceans teeming with life. Below the surface, creatures with thick, muscular limbs scuttle through the dense underbrush. Their bodies are built to withstand the higher gravity, and their movements are slow but deliberate. Narrator: on a super-Earth, life might be slower, more deliberate. The larger size and greater gravity could lead to animals and plants that grow at a different pace, their bodies built to endure the pressures of a more massive world. This could be a place where new forms of life emerge, where creatures that are more resilient and more robust dominate the ecosystems. Episode 8, Tidal Forces and Life's Rhythm. A new planet appears on screen, a small, icy world orbiting a gas giant. The camera zooms in, showing a massive moon hanging in the sky, its gravitational pull causing violent tides on the planet's surface. Huge oceans churn with the moon's tidal forces, creating vast, ever-changing landscapes. Narrator: some worlds may be shaped not by their stars, but by the gravitational dance between them and their moons. The tidal forces exerted by massive moons could have profound effects on the environment of a planet, creating endless cycles of change that could shape the very nature of life itself. Dr. Isabel Reyes, exoplanet researcher: we've seen this kind of extreme tidal environment on Earth, where oceans are driven by the gravitational pull of the moon. But imagine a world where those forces are intensified, where massive tides transform the surface every day. It's in these dynamic environments that life might evolve to thrive in sync with the changing rhythms of the planet. The scene shows strange creatures in the shallows of an alien ocean, their bodies moving with the ebb and flow of the tides. Some creatures appear to have evolved specialized appendages that allow them to anchor themselves to the rocky shores, while others glide effortlessly through the turbulent waters, their movements synchronized with the rhythm of the tides. Narrator: the cycle of life on such a world could be dictated by the tides, creatures that emerge only when the waters recede, plants that grow and die with the shifting tides. Life, in such a place, might be in constant motion, perpetually evolving in response to the powerful forces of nature. Episode 9, The Dark Side of the Moon. A new world is revealed, this time a moon orbiting a gas giant, its surface entirely covered by shadow. A faint blue glow emanates from beneath the surface, indicating that it might harbor life in the depths of its oceans, or beneath layers of ice. Narrator: some moons, locked in eternal darkness, offer a unique possibility for life. Subsurface oceans, shielded from the light of the star. These worlds, where life could exist in complete isolation from the sun, may hold the most surprising discoveries. Dr. Joshua Young, oceanographer. These dark worlds are particularly intriguing because of their potential for subsurface oceans. If these oceans are heated by the tidal forces from the gas giant, they could create environments where life thrives without the need for sunlight. Instead of relying on photosynthesis, life might use chemical energy to survive, much like the ecosystems around hydrothermal vents on Earth. The camera dives beneath the icy surface, revealing a glowing world teeming with strange, bioluminescent creatures. A towering, gelatinous organism pulses in the deep, casting an eerie light that illuminates the darkness. Narrator, in the depths of this alien ocean, life exists in a world without daylight. It survives through a complex web of chemical processes, chemosynthesis, rather than photosynthesis. And in this isolated environment, life takes on forms unlike anything we might expect, evolving in complete darkness, away from the reach of the sun. Episode 10, The Search for Life, The Final Frontier. The last episode takes us back to the stars. The camera pans over distant galaxies, nebulae, and star clusters, illustrating the vastness of the universe. As we zoom in on a distant star system, the camera reveals the intricate network of space telescopes and probes that have made these discoveries possible. Narrator, after decades of exploration, the search for alien life has only just begun. With new telescopes and probes sending back unprecedented data, we are on the cusp of understanding what alien life might look like, and how we might find it. The next generation of explorers will venture further into the unknown, seeking out the answers to questions that have haunted humanity for centuries. Dr. Rafael Ortiz, astrobiologist, what we've learned is that life, in all its forms, is incredibly diverse. From the most extreme environments on Earth to the potential for life on other worlds, we've seen that the possibilities are endless. The search for alien life is not just about finding something that looks like us. It's about understanding the fundamental processes that make life possible in the universe. The camera zooms out into the vastness of space, as the music swells, leaving viewers with a sense of wonder and anticipation. Narrator, the universe is an endless frontier, full of worlds yet to be discovered. And as our reach extends further into the cosmos, we know that we are not alone. Life exists in forms we cannot yet imagine, and the mysteries of the universe are waiting to be unlocked, one discovery at a time. The screen fades to black, and the final words appear. The fungal frontier. The opening scene fades in on a dark, humid planet where the landscape is covered with dense, otherworldly mushrooms and fungal growths. The camera zooms in, revealing massive, towering fungi, some resembling the size of trees. The air is thick with spores, drifting like clouds in the dense atmosphere. Narrator, on Earth, fungi are some of the most diverse and mysterious life forms. But what if the dominant life form on another world is not an animal or plant, but a vast, sprawling fungal network? What if life in alien ecosystems was built on fungal biology, organisms that communicate, grow, and evolve in ways we never imagined? Dr. Lena Tiberius, astrobiologist, fungi on Earth are extraordinary. They can form vast networks beneath the soil, communicate chemically, and even adapt to extreme environments. But what would happen if a planet's environment, rich in moisture, with a dense atmosphere and low sunlight, favored the growth of giant fungi? Life could thrive in a way we simply don't expect. The camera pans through a forest of alien fungi, where massive spore-bearing caps release clouds of glowing spores into the atmosphere. Beneath the fungal canopy, small, bioluminescent creatures dart, moving between the thick roots of the mushrooms. Narrator, in this alien ecosystem, the air itself is thick with spores, flying seeds that carry the potential for new life. The giant mushrooms are not just trees, but living organisms, each a part of a vast fungal network, stretching across the planet's surface. Dr. Tiberius points to a holographic model of the planet's underground ecosystem. Massive mycelial networks, like the fungal equivalent of roots, extend deep below the surface, connecting the planet's life forms in a complex, planet-wide web. Dr. Tiberius, what if life here is not based on individual organisms, but instead on vast fungal colonies? Just as trees in Earth's forests are connected by an underground mycorrhizal network, the creatures here might be tied into a larger fungal organism that governs everything. Life might not exist as separate entities, but rather as symbiotic relationships between species, each contributing to the whole. Episode 12, Frozen Worlds. Life on the Edge. The screen fades into an icy moon orbiting a distant gas giant. The planet is covered in thick glacier, and the surface is shrouded in a permanent twilight. The camera zooms in, revealing an enormous chasm running through the ice, where cracks pulse with faint blue light. Below the surface, the distant glow of geothermal vents can be seen. Narrator, the frozen moons of gas giants, like Enceladus and Europa, may appear lifeless to the naked eye, but beneath their icy crusts, alien oceans could harbor life. These moons exist at the very edge of habitability, where extreme cold, darkness, and pressure might seem to preclude life. Yet, as we have learned on Earth, life can thrive even in the most extreme conditions. Dr. Liam Frost, geochemist, life in these environments may not look anything like what we're used to. In Earth's deep oceans, hydrothermal vents support thriving ecosystems that do not rely on sunlight at all. Instead, life here might rely on the heat and chemicals that emerge from beneath the ice, making the deep oceans of Europa a prime candidate for life. The camera shows a digital model of Europa, with massive geysers of water shooting up from beneath the ice into space, suggesting the presence of liquid water beneath. Dr. Frost explains how these geysers could provide an entry point for scientific missions searching for life. Dr. Frost, the energy needed to drive life may come from geothermal processes deep within the planet's interior. We think that beneath the thick layers of ice, there could be warm, liquid oceans heated by the tidal forces of the gas giant. These could be the perfect environment for microbial life. The camera dives into the icy depths, revealing strange creatures, bioluminescent organisms, drifting through the water near geothermal vents. The creatures are adapted to the dark, their bodies emitting a soft glow as they move in the cold, high-pressure environment. Narrator, in the frozen depths of these alien oceans, life might take on forms unlike any we've seen before, creatures that have evolved to survive in total darkness, using chemosynthesis rather than photosynthesis to fuel their existence. Here, life is a delicate dance between chemistry and extreme conditions, thriving in places where earthly organisms could never survive. Episode 13, The Gas Giants. Floating Worlds. The camera sweeps across a gas giant, its surface alive with swirling clouds of red, yellow, and purple. Gigantic storms rage across the planet, and the sky above is filled with lightning and churning gases. The scene transitions to the outer reaches of the planet, where massive floating organisms drift in the clouds. Narrator, gas giants, like Jupiter and Saturn, are often thought of as inhospitable. But what if the atmosphere of these massive worlds could support life? Imagine vast floating organisms that thrive in the clouds, drifting through the thick, gaseous layers, and using the planet's energy to survive. Dr. Mariana Lux, atmospheric scientist, we've only just begun to scratch the surface of understanding how life could exist in a gas giant's atmosphere. We know that Earth's clouds are teeming with microbial life. Could there be life forms on other worlds, floating through thick clouds, feeding off the chemical nutrients suspended in the air? These creatures wouldn't need a solid surface, they would simply drift, taking advantage of the planet's resources. The camera shows massive, balloon-like creatures floating in the dense clouds of a gas giant. Their bodies are translucent and made of gas-filled sacs, drifting with the winds and using radiation from the planet's storms to fuel their metabolism. Dr. Lux, these creatures would likely be adapted to the dense, turbulent atmosphere, using buoyancy to stay afloat and harnessing the chemical and electrical energy in the air to power their biology. It's a kind of life that defies our terrestrial understanding, living not on land, but in the very sky itself. Episode 14, Worlds in the Twilight Zone. The camera shows an exoplanet orbiting a star on the edge of its habitable zone. The planet's atmosphere is thick, and its surface is bathed in the soft glow of the star's distant light. As the camera zooms in, the planet reveals a dramatic landscape, a line of twilight, where day and night meet, stretching across vast plains and jagged mountain ranges. Narrator: on planets located in the habitable zone of distant stars, life may evolve in ways we can only begin to imagine. These worlds, on the edge of what we call the twilight zone, might not receive enough sunlight to support photosynthesis, but could still harbor life, possibly by relying on alternative energy sources. Dr. Natasha Wang, exoplanet ecologist: in this region of the twilight zone, life may depend on geothermal heat, tidal forces, or even the planet's atmosphere itself. The organisms here would need to be highly adaptable, able to thrive in environments where the day is faint and the night is long. The camera reveals a lush, alien ecosystem growing in the dim twilight, with plants that have evolved to capture and store limited sunlight, and creatures that move slowly, conserving energy in the cold night. Narrator: this could be a world where life uses different strategies to cope with limited light. Bioluminescent plants and creatures, like the deep-sea organisms of Earth, could dominate the landscape. The life on these planets might not be dependent on the sun, but instead use the faint glow of distant stars, or internal sources of energy like heat, to fuel their survival. Episode 15, The End of the Beginning. The final episode takes us to a futuristic space station orbiting a distant star. Researchers, engineers, and biologists gather around a large holographic map of the universe, plotting new missions to explore distant worlds. Narrator: the search for life beyond Earth is a journey that has only just begun. With new technologies, new discoveries, and new missions, we are standing at the threshold of a new era of exploration. Dr. Maxwell Reed, astronomer: we've already made extraordinary discoveries, but the real work is just beginning. Our next steps will take us deeper into the cosmos, far beyond the realms of our current knowledge. Every discovery we make on these alien worlds brings us closer to answering one of the most profound questions we can ask: are we alone? The camera zooms out, showing the space station against the backdrop of a distant galaxy. The stars shine brightly, and the endless potential for discovery beckons on the horizon. Narrator: the universe is vast, filled with mysteries and wonders beyond imagination. As we continue to explore the alien worlds that surround us, we move ever closer to the answers we seek. And perhaps, in the end, the true discovery will be not just about finding life, but about understanding our place in the cosmos. The screen fades to black, and the series title appears: Alien Worlds. The forests of another world. The scene opens with a breathtaking view of a lush, alien forest bathed in the soft orange light of a distant star. The trees here are tall and translucent, their trunks pulsing with bioluminescent patterns. Vines twist and coil in the air, thick with moisture, and in the distance, the calls of alien creatures echo through the dense foliage. Narrator: on Earth, forests are teeming ecosystems, alive with the sound of birds, insects, and the rustle of leaves. But what if the forests of distant planets evolved in an entirely different way? Imagine a world where plants are not just rooted in soil, but float in the air, moving with the planet's winds, their energy drawn from the atmosphere itself. Dr. Clara Michaels, xenobotanist: forests on other worlds might not look anything like Earth's. The plants here could be adapted to environments with different atmospheric compositions, varying levels of gravity, or other unusual factors. Instead of relying on sunlight as Earth plants do, these alien forests might use chemical processes to produce energy. Photosynthesis, as we know it, may not even be the key. The camera zooms in on alien trees, their branches stretching upward like tendrils, slowly undulating in the wind. Instead of leaves, the trees seem to be covered with thin, membrane-like structures that shimmer in the light. Dr. Michaels, on some planets, the atmosphere might contain gases like methane, ammonia, or sulfur, which could serve as fuel for the plants. These plants could develop complex chemical processes that allow them to thrive in environments where Earth's oxygen-based life could not. As the camera moves through the forest, the environment shifts, revealing a startling variety of life forms, some humanoid in shape, but translucent, their bodies covered in small, webbed structures that appear to draw in the surrounding gases. Narrator: in this alien forest, life has adapted in unexpected ways. The creatures here are built for the dense, foggy atmosphere, their bodies designed to absorb the ambient chemicals. Some of these beings seem to float, while others appear to crawl through the thick air, moving in an almost graceful rhythm. Dr. Michaels: the biome of a world like this is not bound to the ground. Plants, animals, and microorganisms all interact in a way that seems fluid, connected by the gaseous environment around them. Life is not rooted in the soil. It is suspended in the air, reliant on the chemistry of the planet rather than the sunlight of the star. Episode 17, The Fermi Paradox. The screen cuts to a quiet observatory perched on a rocky mountain. The telescope is trained on a distant star system, its sensors picking up faint signals that might indicate the presence of intelligent life. Narrator: the Fermi Paradox. If the universe is so vast, and if so many stars host planets in their habitable zones, then why haven't we found evidence of alien civilizations? If intelligent life is out there, where is it? Dr. Ian Holt, astrophysicist: the universe is unimaginably large, with billions of potentially habitable planets. Yet, we've only just begun searching. The question isn't whether intelligent life exists, but why we haven't detected it yet. The Fermi Paradox poses an intriguing challenge. Could we be too early in our search? Or could the signals we're looking for be completely different from anything we expect? The camera zooms out to show vast star clusters, highlighting billions of stars, each potentially home to life. Narrator: perhaps intelligent civilizations are far more common than we think, but they may communicate in ways that are beyond our current technological reach. Our efforts to find other civilizations may be limited by the very tools we use, or perhaps the aliens we seek are simply waiting for us to catch up. The episode transitions to show a digital model of a distant exoplanet in the habitable zone of its star. The atmosphere is rich in gases, and signs of artificial structures flicker on the surface, suggesting that there may be life there, but in forms that we cannot recognize. Dr. Holt: one theory is that intelligent civilizations might develop along paths completely different from ours. Instead of radio signals or optical lasers, they might use quantum communication, gravitational waves, or even biological systems to transmit information. Life might not be speaking to us the way we expect, and so, we miss the message. The screen shows a series of advanced space probes being launched, with the hope of expanding our reach into the cosmos. Narrator: we may not be ready to hear the voices of alien civilizations yet, but every new discovery brings us closer to understanding the true nature of life in the universe, and the startling possibilities that lie ahead. Episode 18, The Silent Signals. The camera shows a starry sky, and the silhouette of a space telescope scanning for faint signals. A signal suddenly bursts to life on the screen, a brief pulse of energy from a distant galaxy. The scientists scramble to analyze it. Narrator: in the search for intelligent life, the discovery of signals from distant stars or galaxies could mark a turning point. But when we receive a signal, how can we be sure it's from another civilization, and not just natural phenomena? Could we even detect the subtle, encrypted messages sent out by alien minds? Dr. Evelyn Reed, SETI researcher: for decades, we've been listening to the stars, hoping to detect a signal that would confirm we are not alone. But the challenge lies in the fact that a signal from an alien civilization could be vastly different from anything we expect. It might not be a radio wave, it could be a laser, or even a pattern in the cosmic background radiation. The camera shifts to show a digital model of the signal, a brief but intricate pulse that seems to emanate from a distant star system. The pattern is highly structured, suggesting intelligence. Dr. Read, what we're looking for is a signal that can't be explained by natural processes. Something too regular, too specific to be random. The hope is that we'll one day recognize such a pattern, an artificial signature that confirms we're not alone. As the scientists analyze the signal, they uncover patterns that resemble a mathematical sequence, suggesting that it could indeed be artificial in origin. Narrator, if we ever confirm that a signal comes from an alien civilization, it could be the most profound discovery in human history. It would change everything we know about ourselves, our place in the universe, and the future of our species. Episode 19, Alien Microbes. The first signs of life. The screen opens on a barren world, its surface covered in frozen deserts and craggy mountains. A probe is sent down to collect samples of the soil, and as it drills into the frozen ground, it uncovers tiny microscopic organisms, preserved for eons in the icy grip of the planet's surface. Narrator, the discovery of microbial life on distant planets could be the first step in our search for extraterrestrial life. Microbes are the most basic form of life on Earth, and they are capable of surviving in the harshest of conditions. But what if they exist in environments we consider too extreme to support life? Dr. Fiona Brooks, astrobiologist. Microbial life is the first form of life we might find elsewhere in the universe. It could be as simple as bacteria, or more complex microbial organisms that have evolved to survive in extreme conditions, like those found in the depths of icy moons, or beneath the surface of desert planets. The camera zooms in on the microscopic life forms, showing how they interact with their environment, growing, reproducing, and using the planet's limited resources to survive. Narrator, even on the most inhospitable worlds, microbes could find a way to thrive. Life, it seems, is incredibly resilient. And even if we don't find advanced civilizations, the discovery of alien microbes would be a monumental breakthrough, proof that life can exist beyond Earth. Dr. Brooks, finding microbial life on another planet would change our understanding of biology, evolution, and even the origins of life on Earth. It could reveal that life is not as rare as we once thought, and that the building blocks of life are scattered throughout the universe, waiting to be discovered. Episode 20, Beyond the Horizon, the future of exploration. The camera pans across a future space mission, where a new generation of spacecraft is being built to travel farther than humanity has ever gone before. Researchers, engineers, and astronauts are gathered in mission control, preparing for a journey to explore a distant star system. Narrator, the search for life is far from over. As technology advances and our understanding of the universe deepens, we are preparing for the next great leap in exploration. The stars are no longer out of reach, and the possibility of discovering alien life is more tangible than ever before. Dr. Adrian Stark, Space Mission Director, we've only just begun to scratch the surface of what's out there. With the next generation of telescopes and space probes, we will be able to look deeper into distant star systems, find planets that are more like Earth, and search for the signs of life that may exist on them. The universe is vast, but we are now equipped to explore it in ways that we could only dream of just a few decades ago. The camera zooms out from the spacecraft as it launches into the stars, leaving behind the Earth, the home of humanity, but aiming for the unknown. Narrator, *, the universe beckons, full of potential.